Hey everyone, it's Mrs. Brimlow, and today we're going to review the Pythagorean theorem. So make sure you have your packet out so you can copy down the examples as we go through them. Before we dive into the packet, though, I want to show you a visual to explain the Pythagorean theorem. So the Pythagorean theorem applies only to right triangles. So notice this has a little box in one of the corners of the triangle or one of the angles. That's a 90-degree angle telling us that it is a right triangle. So the Pythagorean theorem states that if you add the squares of the two smaller sides, their sum is the square of the largest side. The two smaller sides are typically called the legs, and then the largest side, which is across from the right angle, is called the hypotenuse. So if I squared this side, so this side is 3 units, so 3 squared is 9, plus this side squared, so 4 squared, which is 16. If I add it together, it's going to equal the longest side, the hypotenuse, which is 5. So 5 squared is 25. If I add 9 plus 16 together, I'm going to get 25. So we can use this theorem in several ways to solve different problems related to right triangles. So I have a couple of examples at the top. So one way we can use this theorem is to either find a missing leg or to solve for the hypotenuse. Whenever you're given a theorem, that should always be your first step. So a squared plus b squared equals c squared. So a and b are your legs, and it doesn't matter where you put them. It doesn't matter where the numbers go as long as it's in the legs spot. The legs form the right angle, and they're the two smallest sides. So when I'm looking at this problem, another way too to figure out where the hypotenuse is, if you draw an arrow from the right angle across to the opposite side, it points to your hypotenuse. So we're going to be solving for the hypotenuse in this problem. So that means 12 and 5 are legs. So 12 could go in for A or B, it doesn't matter. I usually do my smallest number first. So in this case, 5. And then I would put 12 in for B. But once again, it doesn't really matter. And they add up to equal c squared. So 5 squared is 25. 12 squared is 144. Equals to c squared. So that is 169 equals to c squared. In order to get rid of the 2, the exponent of 2 with the c, I'm going to take the square root of both sides. So 13 centimeters is equal to c. Okay? So the next problem we have a squared plus b squared equals c squared. So I'm going to draw an arrow from my right angle across. So there is my hypotenuse. And I can see if I turn my paper, the legs are formed by 14 and the missing side length x. So I'm going to put 14 in for A. Once again, it could go in for B. It doesn't matter. As long as you leave A or B blank and solve for it. And then we're going to change C to be 20. So I'm just going to solve the equation. So 14 squared is 196 plus b squared. 20 squared is 400. I need to get b squared by itself, so I'm going to subtract 196 from both sides. So b squared equals 204, taking the square root. Now, you could do the answer one of two ways. 204 is not a perfect square, so you could literally just leave it as b equals the square root of 204, and there's no, so we would just say units, or you could estimate it. So b equals, or is about, so 196 is actually pretty close to 204, probably the closest we're going to get. So it would be about 14.2 or 0.3. I'm going to go with 0.3, but it doesn't really matter as long as it's close to 14. So 14.3 units, okay? All right, so we also have what we call the converse of the Pythagorean theorem. So that states that if 3 sides of a right triangle are the two, let me restart, sorry. If I add the squares of the 2 smaller sides of a right triangle and it equals the square of the largest side, then it is a right triangle, okay? So we're going to check this out. So we have 8, 6, and 10. So a squared plus b squared equals c squared. So my two smaller sides are 6 and 8, so those would be the legs if this works, and 10 would be the hypotenuse. So 6 squared is 36, 8 squared is 64, and 10 squared is 100. So if I add 36 and 64 together, that does give me 100. So what that tells me is that this triangle is a right triangle. Now let's say it didn't work. Let's say it was 36 plus 81 equals 100. Then it's not a right triangle. Could the three sides still form a triangle? Possibly, but I don't care about that. I just want to know, is it a right triangle or not? And that's what the converse helps us prove. And there's two examples here to show you that as well. Okay, the last way we can use the Pythagorean theorem that we learned this year is to find the distance of a line segment on a coordinate plane. So I can't just count this. It's a diagonal, it's slanted. I can't count the number of units. But what I can do is form right triangles because my plane is made up of squares. So you could do this two different ways. Let me see if I have a different color. I'll do this one. Actually, I could use this one. So what I can do is I can draw a right triangle. Now, the way my brain sees this when I look at this problem is to draw the right triangle like this. However, you could also draw a right triangle like this. I'm going to use blue. Perfect. Doesn't really matter which triangle you use, it's going to be the same measurements. So this I can count units. So this side of my triangle is 2 units, and this side is 1, 2, 3, 4, 5, 6 units. So now I can use that to help me find that diagonal, which is my hypotenuse. If I draw in my little right angle, I use that trick. So a squared plus b squared equals c squared. So 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. So 40 equals c squared. So once again, 40 is not a perfect square. So you could say c equals the square root of 40, or you could say c is about. So your perfect squares around 40 are 36 and 49. It's closer to 36 though, so I'd say maybe 6.2, 6.3, either would be acceptable. Okay. So this covers most of what you're going to need to know about the Pythagorean theorem.